This is the final example for today. This is a 2-for-1 special. We're going to do this problem because it's a definite integral. And I want to show you how to deal with the endpoints of integration when doing integration by parts. And also, we're going to have to integrate by parts twice in this example. So let's go ahead and start. We have a couple of choices here. We could let u equal e to the x, or we could let u equal x squared. I know that I'm going to have a u prime, and I know that the derivative of x squared is 2x, which is simpler. It's a lower degree polynomial. So I'm going to pick u equals 2x, which leaves my v prime as e to the x. U prime then, u is x squared. Sorry about that. Got ahead of myself. U prime is 2x. And that's why we chose x squared for u, is because u prime is simpler than u is. And also that leaves me with a v prime that I can anti-differentiate. I know the antiderivative of e to the x is e to the x. My antiderivative didn't get any worse. That's good news. So this, I think, is the right approach. Let's go ahead and plug in the formula. So our original integral, x squared e to the x dx from 0 to 1 is u times v. So x squared e to the x. Now with endpoints of integration, I can put those in now. Minus the integral from 0 to 1 of u prime times v. So that's 2x e to the x dx. So I've got a couple of things to do here. The first is put in my endpoints of integration. 1 squared e to the 1 is just e, minus 0 times e to the 0, so minus a 0. And I've got a minus 2 times the integral from 0 to 1 of x e to the x dx. And this is where we need to do parts again. We got to do integration by parts again. It's a little tedious. We're patient. We can deal with it. E minus 2. Now, well, getting ahead of myself again. Let's go ahead and think about what that part is going to look like this time. We're going to have a u of x. I'm going to pick it to be x. That leaves v prime is e to the x. U prime then is 1, and v is e to the x. And that leaves me with e minus 2 times the integration by parts formula again on this second integral, u times v. So that's x e to the x from 0 to 1 minus the integral of u prime times v. So 1 times e to the x dx. I'm getting an integral here that I know how to deal with, which is good news. So I've got e minus 2 times, I'll put in the endpoints of integration here, and I get e to the 1 again, minus a 0, minus the integral of e to the x is just e to the x from 0 to 1. And this all simplifies down to, let's see, e minus 2, e minus e to the 1, minus an e to the 0. E to the 1 is e. Those e's cancel out. And I think this is e plus 2 after changing all the signs and simplifying appropriately. So that's two things there. That's integration by parts twice. In general, you could do it any number of times, but I'm never going to ask you to do it more than twice on any homework or test. And this also showed how to deal with the endpoints of integration. Alternatively, we could have gone through the whole antiderivative process and then put in the endpoints of integration, gotten the same answer. Just waited till the end to deal with the endpoints. That's fine.